If I gave you a problem like this, would you be able to solve it? Well, in today's video, we're going over
sum of roots.
Let's do it.
Alright, let's begin. First problem. What is the sum of the roots of the quadratic equation 0 equals 4x squared plus 32x minus 12? Okay, so let's first understand what the problem is asking for, okay? So it's asking us to find the sum of the roots of this quadratic equation. And so first, let's find out what is a quadratic equation. Where a quadratic equation is simply an equation in which x is put to the power of 2. And on a graph, this looks like a big U, either up or down. Now, sometimes this graph right here, this is always called a parabola. Now, sometimes this parabola will intercept with the x-axis, right? So this horizontal line is called the x-axis. Wherever the parabola intercepts with the x-axis, that is called an x-intercept. Another word for the x-intercept is the root or roots. Okay, so these x-intercepts are all roots. And so what they're asking us to do is they're asking us to find the roots of the quadratic equation, and then we're supposed to find the sum of those roots. Okay, so now let's take a look at this quadratic equation. So we have 4x squared plus 32x minus 12. And so one thing you might be able to see here is that you can take out a 4 from each of these. So that would make this equation 4 times x squared plus 8x minus 3. Now, how will we find the sum of the roots of this quadratic equation? Well, it's actually a pretty simple answer. See, usually to find the roots, what some people would do is they would take this quadratic equation and factor it into its two linear factors. So x plus a times x plus b. Whatever x plus a times x plus b is supposed to be x squared plus 8x minus 3. However, we don't have to do all that because there's a very simple trick. See, if you look at this quadratic equation, this is in standard form of ax squared plus bx plus c. So, whenever you want to find the sum of the roots of a quadratic equation, all you have to do is take the b value, so in this case, the coefficient of this, which is 8. You could also take 32, but we can do 8 for now. So 8, and you're going to take the negative value of that. So negative b over the value of a. So in this case, a is 1 right here, right? Because if it's not written there, we can just assume it's 1. So we have negative 8 over 1. That gives us negative 8, and that's your answer. Now, if we took 32, right, instead of factoring out the 4 right here, we could just do the same thing. See, if you take 32 as the b value, and we take 4 as the a value, negative of 32, or negative b, is just negative 32. And then over a, well, a is 4, so you divide by 4. And in this case, you would still get negative 8. So no matter how you do it, factored or unfactored, as long as you do negative b over a, you will always get the sum of the roots. Alright, next problem. What is the sum of the roots of the quadratic equation y equals 1/4 of x squared plus 16x minus 8? Okay, this is actually a very simple problem. Again, we already have the formula from last time. To find the sum of the roots of a quadratic equation, you always do negative b over a. So let's get our b and a values. We can see here that this equation is in the form y equals ax squared plus bx plus c. This is our standard form. Now, if we want negative b over a, we're going to take the b value, which is in this case 16, and we're going to make it negative. And then we're going to take the a value and put it under that. In this case, a is 1/4. So now we have negative 16 over negative 1/4. Now, here's the thing. We're dividing a number by a fraction. This is kind of hard to do. So how can we make this easier? Well, let's represent this in another way. Negative 16 over 1/4 is the same thing as negative 16 divided by 1/4. And negative 16 is the same thing as negative 16 over 1. Now, when you're dividing a fraction by a fraction, you can always just switch the numerator and denominator and create the reciprocal. So in this case, you would have 4 over 1. And you would flip the sign to now being multiplication. And then you have negative 16 over 1. So this is now just negative 16 times 4 over 1 times 1. So negative 16 times 4, that gets us negative 64. And 1 times 1, well, that's just 1. Any number over 1 is just itself. So in this case, we get negative 64, and that's your answer. Okay, let's look at one more problem. What is the sum of the roots of the quadratic equation 6 equals 3x squared minus 30x plus 17? Okay, this is the exact same as the last problems. However, there is one additional step. See, in the last problems, we either had y equals ax squared plus bx plus c, or we had 0 equals ax squared plus bx plus c. But now we have a number. We have 6 equals 3x squared minus 30x plus 17. So we can't really do our negative b over a because this isn't really what we're looking for. This is not the equation that we're supposed to look at. So how can we find the equation that we're supposed to look at? Well, we can see that this right here is 0, so we can try and bring this to 0 over here. So if we do negative 6 to both sides, then this and this cancel out, making this 0, and this other side on the right becomes 3x squared minus 30x, and then you have plus 17 minus 6. 17 minus 6, well, that's just 11. So this becomes plus 11. So now we can do our negative b over a. And one thing you might not notice, one thing you might have noticed actually, is that even though the a and b values stay the same, it's still always better to bring the number over to the right. Now, let's do it. So negative b, well in this case b is 30, negative 30. So negative of negative 30, well that's just 30. Then a, well a is 3, so we're just going to put a 3 right there. So now we have 30 over 3. 30 over 3, well that's just 10, and that's your answer.
That's it. Thanks for watching. If you found this video helpful, please consider subscribing. I take a lot of effort to make these videos, and I'd really appreciate it.